Welcome to this explainer. Okay, I want you to go ahead and literally throw out your recipe book for a second. Seriously, toss it. Today, we're gonna start treating your kitchen like a laboratory. Why? Because making true, authentic sauerkraut, it isn't some delicate art form. It's an exact science. So here's our game plan for today. We're gonna follow a strict 6-part scientific protocol that totally removes the guesswork. We'll start with the science of sauerkraut, move into precision salting, mechanical breakdown, the anaerobic lock, microbial succession, and finally wrap up with troubleshooting any fermentation failures. All right, let's kick things off with part 1, the science of sauerkraut. And to really get this, we need to completely reframe how we look at food preservation. Think about it like this. Cooking relies heavily on art, heat, a little bit of intuition, right? A pinch of this, a dash of that. But fermentation, it's a completely different beast. It relies strictly on applied microbiology and osmotic pressure. We aren't cooking the food at all. Instead, we're using precise scientific rules to extract cellular water and create this amazing, self-brining, and incredibly safe environment. Which brings us to part 2, phase 1, precision salting. And here's the kicker. Standard volume measurements, your cups and spoons, they completely fail us here because cabbage density varies so much from head to head. So the absolutely crucial thing to remember is this magic number, 2%. Exactly 2% non-iodized salt by weight is absolutely mandatory. No eyeballing it. And why does this matter so much? Because this highly specific salinity strictly favors lactic acid-producing bacteria while completely destroying harmful microbes. Basically, it engineers an environment where only the good guys can survive. The purity of your ingredients matters on a literal microscopic level. You're going to need 1 medium organic cabbage, usually weighing around 800 to 1,000 grams. And yes, it actually has to be organic. Pesticides can inhibit the natural wild yeasts and bacteria we're trying to cultivate. For your salt, go with fine sea salt or kosher salt, but double check that it's totally free of iodine and anti-caking agents. Otherwise, your kraut might turn cloudy and just completely fail to ferment. To prep, simply set aside a clean outer leaf, we'll call that our follower leaf, and then quarter, core, and slice the unwashed cabbage super thinly to about 1/8 of an inch, just to maximize that surface area. Now, don't worry, the math here is actually incredibly simple. All you really need is a basic kitchen scale. Place a large bowl on your scale, zero it out, add your shredded cabbage, and jot down the exact weight in grams. Then, just multiply that weight by 0.02. So, for example, if you've got 1,000 grams of cabbage, multiply it by 0.02, and boom, you need exactly 20 grams of salt. Once you have your exact salt weight, just sprinkle it evenly over the cabbage and toss it all together to coat it. All right, with our salt perfectly measured and our osmotic gradient established, we are officially in part 3, phase 2, mechanical breakdown. Now it is time to literally get your hands dirty. You need to aggressively massage and squeeze that salted cabbage with clean hands for a good 5 to 10 minutes. Seriously, don't hold back. You kind of need to physically attack the cabbage. This mechanical force, combined with the salt, actively breaks down the cellular walls of the plant and rapidly accelerates the whole chemical reaction. And all of that physical breakdown leads us to what's known in the biz as the sweat. This is the resulting pool of liquid brine created when osmosis successfully extracts that cellular water. You'll know you're done when the cabbage basically looks like wet coleslaw, with a nice pool of liquid sitting at the bottom of the bowl. But hey, if your cabbage is still feeling a bit dry after massaging, no worries at all. Just let it rest for about 30 minutes so the salt has more time to draw out the water, and then go in for round 2 of massaging. Okay, moving right along to part 4, phase 3, the anaerobic lock. Because oxygen breeds mold and submersion breeds preservation, this entire phase is all about properly packing our sanitized 1-quart mason jar. There are 3 key components at play here. First up, the shredded cabbage itself. You transfer this into the jar and pack it down super tightly with your fist or a wooden tamper to force out any of those sneaky hidden air bubbles. Next is the follower. Remember that folded reserved leaf we set aside earlier? Yep, that acts as a physical barrier right over the top of the shreds. And finally, the weight. You can use a glass weight or honestly even a little water-filled bag placed on top, just ensuring 100% submersion of the cabbage. By layering these elements from bottom to top, you physically force the brine up over the cabbage, creating this perfect, totally oxygen-free lock. So, with our jar tightly packed, we enter part 5, phase 4, microbial succession. Next, we store the jar in a dark cabinet somewhere between 65 and 70 degrees Fahrenheit. And this is where a absolutely fascinating invisible war begins inside the jar. Check out this timeline. It tracks this beautiful biological succession where different bacterial strains naturally rise and fall. From days 1 to 3, leuconostoc mesenteroides dominates, and it produces a ton of CO2. You actually have to burp the jar daily to release this gas, unless you're using a fancy silicone airlock. Then, from days 4 to 10, Lactobacillus plantarum takes over, which slows down the bubbling but drops the pH to a highly acidic level, specifically below 4.0. Finally, from day 10 onward, Lactobacillus bravi swoops in and develops those complex, tangy flavors we all love. Pro tip, remember to start tasting your kraut around day 7. Once it's tart enough for your liking, simply remove the weight, cap it tightly, and pop it in the fridge. The cold temperatures will literally halt the act of fermentation right in its tracks. And finally, we arrive at part 6, troubleshooting fermentation failures. Let's talk about what happens when your little kitchen lab experiment goes slightly wrong and, more importantly, how you can fix it. So, there are really 2 incredibly common issues you might run into. The first, mushy kraut. This happens if your ambient temperature is too high, like above 75 degrees Fahrenheit, or if you used less than 2% salt. That mistake actually allows enzymes to degrade the pectin in the cabbage way before the flavor even has a chance to develop. The fix is simple. Strictly use the 2% weight rule and keep your jar in the coolest part of your house. The second issue is not having enough brine. This usually happens due to dry cabbage or just poor osmosis. But the absolutely vital rule here, never ever add plain water. If your brine is low, mix up a fresh 2% brine, which is just 1 cup of filtered water mixed with 1 teaspoon of sea salt, and pour that right over the top to make sure everything is submerged. And this brings us to the dreaded visual panic. Please, please don't throw away a perfectly safe batch of sauerkraut. If you see a flat, white, powdery film with a sort of yeasty smell, that is just calm yeast. It's completely harmless. You can literally just skim it right off the top. However, true mold, which is caused by oxygen exposure, is undeniably fuzzy, and it usually comes in spots of blue, green, or black. If you see fuzzy mold, the batch is unfortunately compromised and you have to discard it immediately. But knowing the difference between the two will save so much perfectly good food. Which brings us to our final thought for today. What other invisible microbial ecosystems do you think are secretly preserving the food in your kitchen right now? Armed with the strict rules of applied microbiology we've covered, I really hope you leave this explainer ready to look at your kitchen as a laboratory full of endless, delicious possibilities.